The human brain is like a circuit board. Just like a circuit board, the brain is powerful and complex. It has connections that extend everywhere, and while it can do a lot, it's also delicate and fragile.
A couple of injuries, and it becomes impossible to hear, taste, see, or even lift this spoon. Even though the brain is very delicate, it has its own method of dealing with injuries and obstacles. This is known as neuroplasticity.
Neuroplasticity is the brain's ability to rewire and reroute its circuits and connections. The brain is made of billions of neurons that contain information. Each neuron is connected to other neurons by axons. These axons are like cables that send information from one neuron to another. There are so many pathways that connect these neurons that it's possible to rewire them in order to regain or replicate bodily functions. Neuroplasticity is also used to understand new experiences. Children's brains can easily rewire themselves and create new connections in order to learn new skills and languages. You could think about the axon connections as a path. For this example, the information shown will be sensory information from the tongue. Taste information from the tongue is sent from point A to point B, aka the primary gustatory cortex where taste is perceived. This process works very well, but what would happen if the person suffered a severe head injury? The injury could damage the pathway, stopping information from being sent from point A to point B. This lack of information transport could leave a person without the ability to taste. Now, in the case of the human brain, neuroplasticity allows for the information to be sent from point A to point C. From point C, it can then be sent to point B. Point C wasn't needed for this transportation before, but now thanks to neuroplasticity, the brain could rewire itself so the information would still reach point B. This rewiring gives the human the ability to taste again. In the 1960s, Robert Bem, a citizen of Wisconsin, lost his vision to a degenerative eye disease. In 2007, Robert volunteered to test a device that could possibly allow him to see again. This device was made of a black and white camera placed on Robert's forehead with wires linking the camera to electrodes on his tongue. The electrodes would shock his tongue based off of the color of the pixels in the image. Robert didn't understand the signals at first, but after practicing with the device, Robert was able to recognize household items and even navigate through obstacle courses. Even though the information was taken in through his tongue, scans showed a lot of activity in his brain's occipital lobe, aka the part of the brain responsible for processing visual information. His brain hadn't repaired itself. It instead rerouted information and changed connections in order to take in new visual information from the tongue and not the eyes. Not only is neuroplasticity being used for healing, it's also being talked about for human enhancement. It's only a matter of time until we see its true untapped power.